for the following function, find its inverse, check that it's the inverse, and then check the rule for the derivative of an inverse. So our function is going to be f of x equals 2 e to the x minus 2. If I want to find the inverse function of this, we're going to switch x and y and then solve for y. Okay, so I'll call f of xy. We switch. So, and then we could just start pushing things through. So I move the 2 to the other side. The whole point here is to get e to whatever by itself. Once I have e by itself, I can take the natural log, and then that's going to reduce things to a point where we can work with it. So once I have the e by itself here, I take the natural log. That's going to be x over 2. Natural log on this side is e to the y minus 2. And then you have two options here to collapse this. Either note natural log and e cancel to leave me with y minus 2, or the exponent y minus 2 comes down to the front by a rule for natural log, and then natural log of e is equal to 1. Either way, it crunches down to y minus 2. Pushing the 2 to the other side, we get for the inverse, y equals 2 plus natural log x over 2. We want to check this. So the way I check, I have my choice. I have either f on f inverse of x equals x, or f inverse of f of x equals x. That's the equation we're checking. We can go with either one. So let's go with f on f inverse of x and see where that leads us. So what we do is, I'm going to take a look at f. I'm going to stack f inverse of x into here. So I think of the x in the original equation as just being a big box, and we're going to dump f inverse of x into there. So that's going to look like this. Where I had x before, we're just going to put a big box, and then I'm going to stick the inverse function in. And then we just follow our nose. So then I notice the 2's are going to go away, leaving me with a natural log x over 2. E and natural log cancel out from before. E of x and natural log of x are inverse functions. And then I'm left with 2 times x over 2, which is going to be equal to x. And that means these functions are inverse to one another. For the last step, I want to verify the derivative rule for an inverse. What does that say? That says if I take the derivative of an inverse, that's going to be the same as if I took 1 over the derivative of the function, and then I evaluate at the inverse function at x. So the idea is essentially what it means is if I take the derivative of the inverse, we just flip over the derivative of the original function. Let's take a look. All right, now by hand, we already have f inverse of x figured out, so we can just take the derivative. Let's note, okay, we have 2 plus natural log of x over 2. Taking the derivative, the 2 goes away, and then the rule for natural log says take what's on the inside, flip it over, and then multiply by the derivative of the inside. So what's going to happen there is I take the x over 2, put it in the bottom, and then multiply by the derivative, which is 1/2. We clean that up, we get 1 over x. You might be worried, 1 over x is supposed to be the derivative of natural log. Well, if you note, natural log of x over 2, the rule for a quotient inside of a natural log is just to take the difference on the outside. So what's happening here is our natural log of x over 2 is just natural log of x plus a constant. So when I take the derivative of that constant, we're going to wind up getting the derivatives for this and natural log of x exactly the same, 1 over x. Okay, now let's get it using the rule. So I need to know what the derivative of our original function is. Our original function is 2 e to the x minus 2 times 1. If I have an exponential, say e to the u, the derivative is just rewrite your e to the u and then multiply by the derivative of u. So the 2 we just leave out. This e to the u here just gets rewritten as is, and then I multiply by the derivative of the top. Derivative of x minus 2 is 1. So we just get our original function back. Now let's see what the rule does. So our first step is to take f prime and flip it over. So I'm going to have 1 over 2e, I'm going to call that u for now, minus 2. We're supposed to stick in the inverse function, so I'm just going to put a big box where I had x before, and we're just going to stick the entire inverse function in where box was. Well, this goes exactly as before. This is going to crunch down to x over 2, and then when I clean it up, I get the 1 over x, which is going to agree with what we got when we computed it by hand. So computing by the rule or by hand gives me the same answer.